Hello, everybody. Welcome back. This is the first episode of Season 2 of Coffee Break, the show where we break down interesting topics, all within the time it takes you to enjoy a few cups of coffee. As always, my name is Clifford Swartz, and today I am very lucky to be joined by Andreas Goethe. How are you?
I'm good. How are you, Clifford?
I am lovely, very excited to be back. Before we dive into touch and all things around capacitive touch, I'm going to throw things back over to the booth. Normally we have Wayne Freeman, but my dear boss has thrown someone new to the wolves. Big welcome to Michael Pierce.
Thank you. Yeah, I'm definitely new to the booth. Not new to Microchip, though. I've been here a long time.
Yes, you have.
And Wayne, I heard he was sipping Mai Tais on a virtual vacation somewhere.
That
Is
sounds
right?
like my boss.
Yeah, it sounds like him. So, welcome to the coffee break. First of all, looking forward to the discussion with Andreas. It's going to be awesome.
Me too.
And we're broadcasting live on LinkedIn, Facebook, and YouTube. So please submit your questions in the chat, and we will attempt to answer them after the presentation. There may also be some experts online already that may answer your question before it gets to us. So please share and like. We always appreciate that. And if we don't get to your question, please email us on a live stream at microchip.com. Back to you, Clifford.
Cool. Thank you very much, Pierce. So, Andreas, for a quick overview and background, what is capacitive touch?
Capacitive touch is the ability to interact with the surface without having to press mechanical buttons.
Right.
I think the most common example where we use this on a daily basis would be our smartphones.
Yeah, absolutely. So capacitive touch is something that I see everywhere. Why do people want to design with capacitive touch?
The single word answer would be money.
Okay.
The perception today from a user is if I have a device which is sleek and a closed surface, touch interfaces, sliders, buttons, or touch screens, it's perceived to be more valuable,
right?
Having more content. We have a nice example here where we have, if you read the manuals, these two products, they are thermostats. They are virtually identical.
Mm-hmm.
Cloud connected, Alexa, turn on my AC, all of that thing works with both of them.
Right.
The right one screams to you if you are in the store, I'm this modern type of product.
Right.
The left one, they did everything they can to hide all the good features. And the main difference between the two from a perception, from your user, from your customer perspective is there's a touch interface and then we have mechanical buttons.
And I know for at least myself, when I look at the thermostat on the right, it's something that screams to me, it's an easier experience, right? The UI seems more intuitive for me, and that's the use of like customizable buttons or just ease of use in general with touch.
Exactly. And this is kind of the good experience we have all days on our smartphones. People expect this in other devices as well.
So we've seen thermostats and we've mentioned smartphones. What other devices do we have touch in that we don't expect touch to be in? Because it's everywhere.
It is. One good example would be you go to your car and in many new modern cars you just grab into the door handle and the car by some magic unlocks itself. So that magic is a key exchange between the car and your car key.
Right.
It's also microchip powered, but that by the way. And that key exchange is pretty power intense, so it needs to have a trigger.
Right.
Your car is right now parked outside. Your car is not looking for your key right now. In order to start your car looking for the key, it is your fingertips grabbing into the door handle, and there's a proximity capacitive sensor inside, detecting your fingertips going into the door handle, and then you have like 20 milliseconds to start the key exchange, find the key, unlock the door, and by magic, open your car.
So all this magic really starts with capacitive touch.
Exactly.
Cool. So where does somebody get started if they want to design touch within their applications?
Yes. So when you go into a new area of an application, I think there are three main pillars you want to cover.
Okay.
When you do touch on an MCU, it's clear to you I will have to have code, some touch code. So where is that touch code coming from?
Right.
Then after you have your MCU and your touch code, please give me some quick and dirty hardware where I can just implement touch and just see how it works.
Yeah.
Later on, I will have to design my product. But to get started, I want to start quickly. And then we will talk here for 10, 12, 15 minutes.
Quick.
Quick. So touch, then there's a little bit more to it. So where do I get best case online, where do I get guidance, videos, step-by-step guides in order to learn on my own pace.
Right, to learn the next steps.
Exactly.
So which one of these do you want to break down first of those 3 pillars that you were talking about?
I would like to start with the code
Cool.
configurators. Because it is important to understand, if you do touch with Microchip, there is no need to code the touch at all.
Okay.
We already did that for you. So usually when you want to realize a function inside an MCU, you will crawl through 1,000 pages of a data sheet, find the right registers and peripherals on that part to do what you intend.
Right.
So you have to do some research, some testing. You need some expertise in order to get all of that.
Absolutely, and there's a lot of iteration with that,
Yes.
right? Yeah.
And then you are eventually happy with the functionality. Okay, then you have your touch interface programmed, and then you programmed your actual application. This is where you, first of all, came to that MCU to do your application.
Right.
But in order to do your application, you have to do your touch first. With Microchip, we go completely rid of this whole implementing of touch. We have code configurators, and here's the philosophy. You go to the code configurator, we have some examples later, and you tell the code configurator, which is a visual GUI in your PC,
Right.
I have these 3 pins. I want to connect a 3-segment slider to that pin, and that slider shall be called volume. And you don't code touch, water tolerance, noise tolerance. You just tell the code configurator what you want to do
Right.
on which pins. And then the code configurator does the magic for you, configures your code, and then you can focus on what you actually wanted to do, is writing your application.
And so this GUI is genuinely like a drop-down menu or checkboxes or
Yeah.
text fields so that you can name these devices, right?
Absolutely, yeah.
And I think that's kind of amazing how easy it is to just get up and running with this the code configurators.
This is what our group is all about, to make we want you to use touch, but we don't want you to spend time on creating a robust touch.
Right.
So, and then the whole code configuration process, so we have several of these code configurators, depending if you have an 8-bit or a more complex 32-bit MCU. The good news is that the configuration takes you, if you do this first time, let's say half an hour. If you do the second time in 10 minutes, you have
That's
configured.
quick. That's incredibly
It's
quick.
pretty quick. Then Microchip offers several families of MCUs. The important news is, after you configured your code, you will spend the rest of your product development with testing. The overlay will change from one plastic material to the other. You might have to retune buttons.
Sure.
Some marketing guy tells you the button needs to be bigger or smaller, all of these real-life things.
Right.
And the tuning of your touch project, regardless on which MCU you are actually working, will be done with the same set of tools.
Okay.
It's MPLAB data visualizer. Meaning, let's say your first project you do on a 8-bit PIC, your next project is on a 32-bit. It would be the same tuning experience for both of them.
Cool. So just to reiterate, regardless of the IDE that somebody's using, there is code configurator, there is a GUI for people to use regardless, right?
Absolutely, yeah.
Cool. And it's kind of an amazing thing. You threw up there the data visualization
Yeah.
tool. Do you mind talking a little bit more about that?
So code configuration is your first step. So then you have, let's say, you have a touch button, and then you have to tune that button for your use case. Maybe you want to support gloves, or you want to check if you spray water on the button, that should not false trigger. This is
Right.
all that things we support. But you need, for instance, a threshold to define what type of press do you want that your button is activated.
Right.
And so there are some standards what you want to visualize. So I want to see the raw data out of my touch button. I want to see the threshold. I want to see that when I touch, my raw data goes above the threshold. That noise to the signal will not get me into any type of trouble.
Cool.
So that type of visualization, when you generate your touch project, there is one click you can do. I want to debug or want to tune my touch later on, and then we just stream out via UART all the data needed. And we give you the data visualizer, which visualizes you all the necessary data in a nice predefined way that you can do all of that also out of the box.
Nice.
You don't have to spend time on it.
I love it. So the first part of the column we just discussed was the code configuration.
Yeah.
The next part, I think, would be the actual hardware that people can use.
Yes. So actually, configuring the code is fun, but now the actual fun starts. I want to see that live.
Right.
I want to go to my boss and show him that slider beats the old implementation we have in the old version of the product.
Makes sense.
So in Touch DevKits, we have this like in 2 families. We have complete DevKits which involve everything on one PCB. The chip, there's a debugger. You don't need much more than a USB connection, and then you have, for instance, on the left side, you need a small touchpad. This is a solution which is widely used in headphones.
Right.
Up, down, changes volume. This is gesture detection built in. So we have DevKits which are one piece, and then everything is included. And then on the right side is more like a mix and match experience where you might want to use an 8-bit controller, or you might want to use a 32-bit controller. You might need a touchpad or a slider or a bunch of buttons.
Right.
So you can basically select, every MCU has a starter evaluation kit, Explain Pro board or Curiosity Nano board. Then we have these touch extension boards with different features. And you can just, this is my MCU, and I want to do a small touchpad. You click them together, and the code configurator.
And you're ready to go.
Yeah.
Cool. I like that. I like that a lot. So that was the second column. The last part of this equation is where can people go after this coffee break? Where can people go to get guidance?
Exactly. So it's all online, and we whole Microchip, we summarize everything available in terms of documentation, application support at microchipdeveloper.com.
Right.
There's a section for touch, and there you find video tutorials, step-by-step guides. We have, most of our documentation is like double. Some people prefer to have a YouTube video where they can stop and play pause at their own speed. Others like to read through a PDF with a 1, 2, 3, 4, 5 step-by-step guide. We have both of that.
Makes sense.
And then on the microchip.com page, again, very simple, /touch. There you come to our design center, and there a lot of documentation. The main documentation is the touch design guide.
Nice, and they can find that on microchip.com/touch.
Right there.
And just to reiterate, I guess, all links will be in the description, and we'll be, I'm assuming, throwing them out in the comments as well, directing people to it. I think that's all for the presentation
That's
portion.
what we wanted to bring to the world.
Cool, I think you killed it, and now we're going to throw it over to Mr. Pierce again and see if you guys have any questions for us.
Oh, there's a couple of questions on there, and I apologize if I pronounce your name wrong.
I forgive you.
Not yours. You're Clifford, right?
For
Yeah,
now.
Yeah. So this is from Al-Waleed. What are the suitable microcontrollers for using with touch?
I have to admit, I didn't understand the question.
Okay,
so
I'll rephrase it.
Okay.
Then. So what microcontrollers can you use touch with?
Okay.
So
We have, from an architecture standpoint, we have 8-bit PIC microcontrollers, PIC 12, PIC 16, PIC 18. They are all supported. Close to every single PIC out of that family is supported in touch via MCC. Then we have the 8-bit AVRs.
Yep.
80tiny, Atmega, the new AVR DA, everything supported through START. And on the 32-bit side, we have the SAM controllers and PIC32 controllers, which are also supported on touch. So from I think Microchip has like 1,000 plus microcontrollers.
it's a lot.
It's a lot. Just by counting families, there will be 50 plus microcontrollers doing touch. If you count all the different packages, you have several hundreds.
Right. Cool. What else you got for us, Mr. Pierce?
yeah, how do I design my PCB for touch is another one.
Yes. So having the right code is one part of the story. Having the best code with the wrong PCB layout doesn't give you a good touch experience. So
Right.
you need both. That's absolutely right. We just had on the last slide, there is this touch design guide, application note 2934. There will be a test afterwards. So it's the one number you should remember. The touch design guide is unified. It doesn't matter if you run your touch on a PIC, on an AVR, on a SAM, on a PIC32. It's always the same layout. And the design guide is a single document covering everything we do.
Cool.
So that's the document you want to look into.
Makes sense. Anything else?
Okay, let's have a look here. Yep. So is there like a video or step-by-step guide on how to set up the touch and the code configurators?
Absolutely. That would be on microchipdeveloper.com. And in the touch section, there are 3 subsections then for every code configurator, being MCC, START, and Harmony3. And there is for every code configurator installation guide. There is a guide for your first project using one of our dev tools. And then there are additional guides for, okay, I have my touch running, but I want to deep dive into low power. I want to deep dive into water tolerance. And then you have all these guides on microchipdeveloper.com.
Cool.
And there's another question. It says, does Sony use Microchip in their headphones with Cap Touch in the ear cups? We do.
I'm not in a position to answer that, but
Okay, so can we
would
use
be
it
happy if you buy it.
Yeah. Yeah. So can you explain some of the headphones that we had on display at, I think, CES?
Yes.
So I saw a whole bunch there when I was there. They had sort of sensors in the headphones there.
Exactly. So headphones, I think 7 years ago or so, started to become wireless.
Right.
So, and for the simple reason not to be tangled to your phone.
Yeah.
These days we couldn't even connect the headphones anymore. But at the time, there was still the option to have a wire. And then before headphones were wireless, the wire was maybe tangling, but also had a nice feature. There was a small remote.
Right, you could control what you were listening to.
You could control what you do, right? So now that you removed the wire, you by the way, also remove the remote. So now you can naturally control everything on your phone.
Mm-hmm.
So like right now, my phone is somewhere else in this room. So the phone is not always the best remote control for everything.
Right, let's say you're running or something like that, and you
So-
can't really just easily pull out your
And
phone.
You don't want to select out of 500 titles your next track. You just want to
Right.
skip to the next one. You have a very simple interaction. So how do you do this on a wireless headphone? So technically, you could use buttons,
Mm-hmm.
but there's a human limitation. Your eyes are kind of looking forward, and it's hard to see your ears.
Right.
So finding a button on your ear means you have to tap constantly until you find it while you're listening to music. It's not a good user experience. A touch button would not help you either because you would not feel where the button is. So it's kind of the solution is, and this is also supported from our touch out of the box. You turn your whole ear cup into a touchpad. So now you have to find your ear instead of a specific position on your ear. And then, if this is my ear simulator here, you basically touch down with your finger somewhere and then you move upwards
Right.
to increase volume. You go downwards to decrease volume. You stay down with your finger to ramp volume. You ramp usually up, so you go up and then you ramp volume up until the point where you need it.
Sure.
So you have a touch-sensitive ear pad, and you detect gestures on that pad.
Right.
And we do all of that right on chip, which is a power consumption issue. You don't want to have a second chip thinking about your touch locations. We do this all on one chip, and this is part of our touch library.
Right.
And then you will know the answer, the code configurator. You would tell, I want to have touch locations and gestures, or gestures only, and then you can create your user interface that way.
Then you're good to go.
Good question, thank you.
Okay, here's an interesting one
I'm excited.
from Corey Town. Could you design a wheelchair cushion that uses touch to inflate and deflate the air in the cushion using body pressure and touch?
Yes.
Yeah.
This is a mix of pre-sense detection. So first of all, you would want to know if someone is sitting
Right.
in the chair itself. These use cases we have. One of the modern use cases for pre-sense detection would be it's in a car. We have autonomous driving, half autonomous driving, generation 3, 4, 5.
Mm-hmm.
These days, you want to know, the car needs to know if you are gripping the steering wheel with your hand.
Of course.
Even if the car is driving by itself, it needs to know that at any given moment you could take over. Therefore, there's a new functionality called hands-off detection. So the critical path is not to have the hands on the wheel, it's a question if you take your hands off. That is what the car needs to know. This is the same use case, basically. You're riding from Phoenix to LA, you have your hands 8 hours on the wheel. So this is the same question here. So you can have a pre-sense detection for a chair. The more tricky question will be, you said you want to measure the pressure. So now, can this be done capacitively? This needs to be evaluated.
Okay.
Capacitive sensing will sense in the first step your proximity, but if it also senses how much you decompress foam, that we would need to look into.
Okay. Good question. I like that.
Okay, and a question from Gerald, or Jared, sorry.
Yes.
What about earbuds?
Yes. We do have earbuds from several global vendors. In the earbud, you do with touch usually two functionalities. Earbuds tend to be very, very small. So very small battery inside. So you want to, if you take your earbuds out of your ear, it's best to stop music and or the Bluetooth transfer immediately, because you would, at that moment you take it out of your ear, you would start wasting battery.
Right, you're not
lifetime.
using it.
So one sensor for touch in the earbud is the in-ear detection,
Okay.
which turns the whole Bluetooth and all that transfer on and off as you need it. And then depending on the design of your earbud, that can be round shape, where you have most of the time you have just a tap or double tap, triple tap experience. This is touch. You have other earbuds which are a little bit prolonged. We have several vendors using then a slider on these earbuds where you can change volume there.
Makes sense. Cool.
So yes, short answer, touch can be used in earbuds.
Nice.
Okay. So I think that's about it for now. There's some more questions that have been answered online, but I think it's time to wrap it up.
Cool.
Thank you.
Thank you very much. And if we didn't get to your question, make sure to email us at livestream@microchip.com, and I'll send it over to Andreas.
Thank you.
But I'd just like to say a quick thank you to everybody behind the camera, Andreas for presenting to all of you guys,
My
and to the viewers to listening. And we couldn't do it without you guys, so thank you very much. Like I said in the beginning, this is the first episode of Season 2. We have 5 more, I believe, and over the next couple months, we'll be very happy to bring those to you. As always, my name is Clifford Swartz, and I will see you guys in 2 weeks. See you.
Bye-bye. Thank you.